Hi everyone, my name is JP Cedino and I am a technical solutions architect with Cisco. Today we're going to be looking at Cisco's software-defined multi-cloud firewall, or we can just call it CSW or Cisco Secure Workload for short. Now, most of my customers, and I would bet yours as well, are moving some workloads, all workloads, to the cloud. Most, if not all, of the customers that I deal with on a daily basis have some kind of cloud-based initiative, and most of them are operating in what we would consider a hybrid cloud model, meaning we have certain workloads in a public cloud deployment, so maybe we have web servers or we have some forward-facing applications for our organization out in a public cloud provider somewhere, but then we also have some back-end on-premises workloads. We tend to call this maybe a private cloud, where maybe we have some database services, or we have obviously some Active Directory and login services. You know, we have something that's also on-prem as well. And we're operating in this hybrid cloud model. And again, most of my customers are actively pursuing the cloud for a number of different reasons. Some of my customers are going cloud first. So any new application that they're going to deploy, or any application that's currently on-prem that's approaching its life cycle where it needs to be upgraded, is going to go cloud first. And a lot of my customers are looking at cloud first and a serverless infrastructure. Well, what does that mean? That means that we no longer have to maintain our own servers, our own operating systems. A serverless infrastructure is where your cloud provider, whether it be AWS or Azure, maintains those services for you. So think of a database service. Think of maybe RDS, for example, in AWS. We're going to use this in our example, which is why I'm bringing it up now. You know, maybe we don't want to constantly maintain those operating systems by ourselves. We want to be able to leverage the cloud provider's infrastructure, the cloud provider's operating systems. We want them to worry about all of that. And we just simply want to leverage those back-end services and back-end database services. So there's a lot of different components and there's a lot of different things that play into this. And again, every customer that I deal with has some cloud-based initiative. And this is actually, while it's meant to simplify our environments, it's actually making things much more complex, because now we have workloads that are spread across multiple different infrastructures. We have to learn how to manage these workloads. When I say workload, I mean, you know, an application server, web server, database server. That could also be an email server, whatever it may be. Not only do we have to manage these workloads across this hybrid cloud infrastructure, but we have to secure them, right? We just don't put servers out there on the interwebs for somebody to compromise, right? We need to secure it, and this is where the challenge comes in. We need a system that's able to secure our entire environment and provide us with a singular view, right? In other words, one place that we can go to provide all the security mechanisms, rather than having to learn, well, how does Azure, do its security groups versus AWS versus Google Cloud versus Rackspace versus all these others. How about we just have one system that's going to secure our workloads for us, rather than having to constantly go back and forth and try to reinvent the wheel. So here's the infrastructure that we're going to test with today. Here's the AWS cloud deployment that we're going to work with. Now, as you can see, we only have a single VPC. So this application is built in, obviously, AWS. Oh, let me get my pen in there. AWS, we only have a single VPC. So we're not going to be going cross VPCs. We don't have a VPN tunnel connecting our on-prem into AWS. Our entire application is going to be deployed in AWS. But we've built it for high availability. So we've tried to make this realistic, right? How would you actually deploy a web-based application? So we have our internet gateway. This is where obviously inbound connections are going to come in. They're going to get distributed across our NAT gateway. We do actually have an application load balancer in here. I just didn't put it in the diagram, but we do have an ALB there that's distributing the load. Then we do have Amazon Linux 2 instances. We actually have one instance in each availability zone. So you'll notice here that we have two different AZs, because again, we want redundancy, right? If I lose an availability zone or I lose one server in an AZ or any component thereof, I want to have redundancy built into this application. So we've built it to be somewhat realistic. And then on our back end, we're actually leveraging Amazon RDS services for our database infrastructure. That is redundant. So we do have that database being replicated across security zones, across availability zones. And again, this is a serverless infrastructure. This is Amazon providing our backend database services. And then when you think about deploying a web-based application for high availability, you don't want to constantly have to go and maintain a localized file structure for that web server, right? You don't want to have to constantly go in, reinstall the packages, reinstall the web services, reconfigure, whatever web server you have. And so what we're doing is we're actually leveraging Amazon's EFS file system. So this is actually an NFS share. By the way, I am left-handed, so if I write over here and it kind of gets a little crooked, I apologize. And so our EC2 instances are Amazon Linux 2 web servers that are basically just very simple Linux-based servers. Again, they're Amazon Linux 2. They're just running Apache. That's literally all they're doing. And they are presenting what we have back here in the file system, and they're leveraging Amazon's RDS services for their databases. Now, there's a couple of housekeeping items that I want to point out before we pivot to the AWS console, because I want to show you some of the challenges with deploying something like this. We are accepting Amazon AWS flow logs. So within AWS, I've gone in, and in every single subnet, you'll notice that I do have everything built in different subnets. So I have multiple private subnets. I have 2 public subnets, basically duplicating the infrastructure across both availability zones. I am exporting the flow logs from every subnet, regardless whether I have a CSW agent there or not. I am exporting those flow logs into Cisco Secure Workload, or CSW, if you hear me just use the acronym. Now, I've also installed a CSW agent, a software agent, on my Amazon Linux instances, on my EC2 instances. And so this is going to allow us to just gain a little bit more visibility into what these web services are doing, who they're talking to. But all in all, what we should see when we map out this application is we should actually see the diagram that's in front of you. Now, I'm going to go ahead and pivot over to the Amazon console, because I want to show you some of the challenges with this application. So I've logged into my AWS console, as you can see, and there's just a few things that I want to show you really quick here. So if I go into my VPC, you'll notice that I do have, again, multiple subnets built out for each tier of my application, right? So remember, we have 2 availability zones. So we have US East 1A and 1B, and I have a subnet for each tier, right? So we have public AZA, that's availability zone A, AZB, and then we have the app tier and we have the data tier. So I'm taking in the flow logs from each one of these subnets. Now, disclaimer, if you are architecting a cloud application, this is the easier way to do it. It may be a little bit more to set up and a little bit more to manage, when you first set it up. But if you put the entire application in one subnet, that is going to make things a lot more difficult, a lot harder for you to manage as you start to scale this out. So by doing this, it does make things a little bit easier for us to actually maintain. But there is something I want you to be aware of. I'm going to come over here to security groups, and I want you to see how many security groups that I actually have for this application. So I could probably get away with 4 security groups, maybe 5, but all in all, I have 7. In fact, let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8. I have 8. Technically, I have 8, but I was not counting the default when I said 7. So if you look at my application, I have 7 security groups that are responsible for maintaining security within this application. This is just one application. Are there security groups that I might be able to reuse in another application? Sure, maybe, possibly, maybe not. And this is what I want you to be aware of. And this is where the complexity starts to come in. I have a security group that's going to secure my EFS share, and one that's going to secure my RDS services. I have one that's going to maintain management, right? Am I allowed to SSH into any of my instances? And if so, where? I have a security group that's going to maintain the external connections that are coming in, right? You're not just going to have web services out in AWS or any cloud provider where you just allow anything. You wouldn't do that in your own on-prem instance either, right? In your private cloud. So, we have multiple different security groups that are maintaining who can talk to who, what can talk to what ports, protocols, etc. So for example, if I go click on my internal web security group, you'll notice that I'm allowing port 80 and 443, but only from my external group, right? So as web traffic comes into my external group, only traffic from that, load balancer or NAT gateway is allowed to talk to my internal web servers. So this gets really, really complex, really, really fast, and it's really hard to maintain at scale. So as you start to build out 100 applications, this gets really, really tough to maintain. Not to mention the fact that when you go and you create your security groups, you need to know what those ports are. So for example, do I know when I get back to my data share here, I have port 3306. Now I can Google that MySQL instance and I can say, yeah, okay, I think all we need is 3306, but is that all we need? Are there some back-end services that maybe AWS is going to need for management purposes? I mean, we don't always know what we're building in AWS. I mean, Google's white papers, they say what they say, but is that always true? So let's pivot over to CSW, Cisco Secure Workload, and let's actually see how this can help us to not only make sure that we're securing our application the right way, but help us to actually secure it without making a ton of infrastructure changes. So I've logged into my Secure Workload instance, and what I'm going to do is I'm going to come over to my segmentation tab, and we're going to create a new workspace. So what I'm going to do is I'm going to ask CSW to analyze everything that it finds within my AWS infrastructure. And you can see that it's already identified that we have a number of different nodes within this space. And I'm just moving things around here so that they make a little bit more, my OCD is going to light up that they're not lined up. But anyway, you can see that we've already identified, based on a number of different things, we're tagging different things within AWS. So really quick, I just want to pivot over there and show you that. So within Secure Workload, we do actually have AWS tagging. So what that means is that we're connecting into our AWS instance. We're actually snagging any name tags or any, when you create an EC2 instance, when you create anything, whether it be a NAT gateway, load balancer, doesn't matter. You can give it different tags. So we are ingesting those tags automatically into Secure Workload so that we can start building things based on a name. So if we've labeled it as RDS within AWS, we're ingesting that within Secure Workload, and so we can paste a bubble. Hey, you have RDS in here. We're seeing these things based on those labels. So what I want to do is I'm going to ask Secure Workload to go all the way back to, January 31st at 1 in the afternoon. That was when we first built this lab. You can see that traffic has increased since then, since we've added some things. I want to ask Secure Workload to do a deep policy generation here, so I want it to ingest as much as possible. There's one thing I'm going to do. It's just a little advanced option here that I'm going to check. I want CSW to basically show me where the internet plays into my application. So I'm just going to go down there and add that option. I'll go ahead and say submit. Now, while we're waiting for this to run, I'm going to pivot back over to my AWS console because I want to just see, I want to show you guys a few different things while we wait for that. So we're going to go into my EC2 instances here. I want to load up an EC2 instance because what I want to do is show that we do have east-west movement being allowed at this current time. So what we'll do is let's just grab the IP address of web demo 2. So that's 4.85 or 185. We'll write that down. Let's go ahead. We'll go over to web demo number 1. We'll go ahead and say connect. We'll go ahead and leverage Session Manager here. And we'll wait for this to open up. And then we'll go ahead and escalate our privilege here. We'll say ping 10.0.4.185. And you can see that web demo 1 in availability zone A or 1 can reach web demo 2 in a different availability zone. So clearly we have a working server environment here. Let's go back to my EC2 instances, and what I want to do is I'm going to come down here to my load balancers because I want to actually make sure that my application is actually working. So I'm going to come over here, grab my DNS name, and we'll just open up a new tab. We'll go ahead and paste. We'll paste that URL in, and there we are. There we have our application. So we can see that our application is actually working. We can see that we can move laterally. So essentially, if somebody were able to compromise this particular application, we could go between servers. Again, these two web servers live within a security group. And again, I don't want to constantly have to create new security groups to limit access. I don't want to have to maintain all this. And so we're going to leverage, again, Cisco Secure Workload to do this. So this is about 20% done. What I'll do is I'll pause the video, and I'm going to wait for it to be 100%, and I'll just click record once it's done. Okay, so we're done. I'm going to click results available, and we'll go ahead and we'll click on policies. Now, what's really interesting is you're seeing this live. This is a live demo. I haven't done anything to tweak this. You're seeing exactly what Cisco Secure Workload has mapped out for me. You're seeing all of the backend dependencies. Let me just move things over here a little bit. You're seeing all the dependencies of my EC2 instances. You're seeing where the RDS databases come into play. You're seeing the backend dependencies on the EFS share. You're seeing the dependencies on the front end NAT gateway. So you're actually seeing internet traffic going in and out of the NAT gateway. You're seeing internet traffic going in and out of both EC2 instances as well as the NAT gateway in one availability zone. If I click on the other NAT gateway, you see the same type of traffic. In fact, one interesting thing is I only see traffic going from the NAT gateway into the EC2 instance in one availability zone. I don't see the bidirectional traffic. So maybe that's a misconfiguration on my part. And this is one of the beautiful things about CSW is that it's not just a product that is going to give me policies and secure my environment. It's also something that's going to allow me to possibly see misconfigurations. In fact, before I recorded this video, when I set this up yesterday, I did actually spot a number of different things that I had misconfigured and went in and fixed them because of this. So again, if I click on one of these arrows here, we'll just pick on this one. You can see that I do have an NFS requirement from that EC2 instance going back to my EFS share. Again, if I click that EFS share, if I click this EC2 instance, you can see that. If I click this EC2 instance, you can see that. So what I want to do here for a minute is, if I come back over here to my session manager, again, we saw that we had some east-west movement within my EC2 instances. Now, I don't want to have to go and recreate the wheel here. I don't want to have to go and constantly change security groups, create new ones, delete old ones, etc. And plus, I may have some back-end dependencies here with on-prem servers that I also need to maintain and monitor and secure, and I don't want to have to make, again, what could be multiple security group changes as well as multiple changes to physical firewalls in my environment. So what I want to do is I want to look for any ping traffic that is allowed within my environment. And we do see that we do have some ping traffic. Now, I'm not necessarily concerned with ping traffic going between my NAT gateway and the internet, but I am concerned with ping traffic going directly from the internet maybe to my EC2 instance. Now, keep in mind here that there is an application load balancer that is inside of this internet bucket. I just have it set up that way. You don't necessarily have to do that. That's just the way that I have mine set up. So what I'm going to do is I'm going to remove those allows. So essentially what I'm going to do here is when I push down this policy without making any changes to my security groups, what I'm going to do is I'm going to tell my we'll remove ping going outbound as well. We don't have ping there. So what I'm going to do is I'm going to tell my EC2 instances that not only are they not allowed to accept any ICMP traffic inbound, but I don't want them to be able to ping outbound either. So what I'm doing is I'm removing all of the ping traffic with the exception of maybe from the internet, from my internet gateway going into my NAT gateway. That I don't necessarily care about because I have some other firewalling happening there. But again, I don't want any ping traffic going back and forth. So what's really nice here is that if I remove this filter again, not only was I able to make the policy changes that I need, but I'm also, again, able to see all of those back-end dependencies between my SaaS or serverless infrastructure, right? Keep in mind that I do not have any CSW agents on EFS. I do not have any in RDS. I do not have any in the NAT gateway. And yet, we can still see that traffic going back and forth. What I'm going to do is I'm going to come over to the Enforce tab, and we'll go ahead and click Enforce. Now, what this is going to do is this is going to bring us through a small, like, click next wizard. It's going to generate all the policies for us that we're going to review if we want to. We've already done that, so I'm not necessarily worried about it. You will notice that this is a whitelist policy, so the catch-all is deny. So essentially what's going to happen is anything that has not been whitelisted and allowed by our policy is going to automatically be denied or blocked. Again, that ICMP traffic. So we'll click Next. It's going to let us know that it's about ready to push down policies to these two EC2 instances, these web demos. We'll go ahead and click Next. This is going to be where it's going to tell us exactly what those impacted policies are going to be. So once this is finished generating, what we'll see here is we'll see the window come up. And there it goes. So it lets us know exactly how many policies are going to be pushed and what we're going to do. Again, we'll say Next. This is where we can give it some policy description. Again, I'm just going through these really, really quickly. We'll go ahead and say Accept and Enforce. Now, what we'll do here is I'm going to pivot over to the workload profile. This is where we store all the information about those EC2 instances. And while we're waiting for those policies to be pushed, it'll take about 15 seconds. I want to just show you here that we are in fact integrated with AWS, and we are bringing in those AWS labels and tags. And so as I turn up an EC2 instance, or as I turn up a serverless anything, I am bringing in from that orchestrator automatically what those things are. So if I wanted to group things together based on the fact that they are in a certain VPC, if I wanted to do that, if I wanted to group things together based on a naming convention that I'm giving servers within AWS, a cluster ID, a machine ID, whatever ID that I want to give things within AWS, I can automatically inject that information into Cisco Secure Workload without having to jump through hoops. So you'll see that while I was talking for that 10 or 15 seconds, all these policies have been pushed down to Web Demo 1. So again, I haven't changed anything within AWS. So if I go over to AWS here, if I go over to my WordPress application, if I click on Hello World, we have not broken the application. You can see that my Hello World blog post comes up. But if I head back over to Session Manager, if I hit the up arrow once and I just simply try to ping Web Demo 2, you'll notice that now it fails. Because again, what we're trying to do is we're trying to understand our application while mapping it out, while being able to critique what kind of traffic we want to allow, how do we want the application to actually interact with different components, and then within that same screen, within that same user interface, push down a policy that says, hey, don't allow this traffic, only allow this traffic, you're only allowed to talk to this RDS instance, or you're only allowed to talk to this backend serverless infrastructure. We don't want you just talking across the world. But again, I didn't overcomplicate things, right? I did not come over here. I did not create, any more security groups other than the 7 that I already have. I was able to do this all within a single platform. And I'm going to leave you with this one fact. Had this application, if I come back over here, had this application spanned across an on-prem infrastructure, we would see those dependencies as well. So if you can imagine, another bubble over here that maybe says on-prem database server, if there was a dependency between those EC2 instances and that on-prem database server, we would see that as well. We would be able to either restrict that or allow that based on whatever we want to do. We would not have to make firewall changes, and we also would not have to deal with any security groups or any network changes there. We'd be able to orchestrate all of that right from Secure Workload. So I hope everyone enjoyed this video. I'll see you folks in the next one.